Welcome everyone to this session. So we have a lot of exciting announcements on Spanner today. And in addition to that, we are going to talk about CERC and how CERC disrupted the exchange receivables market with Spanner. So before I do that, let me introduce the presenters to you. My name is Vaibhav Govil. I'm Director of Product Management at Google. I'm joined here with Silva, who is the CIO of CERC. And then both of us are joined by Pritam Shah, who is Director of Engineering in Google. We have a packed agenda today. So first and foremost, we are going to talk about some of the recent enhancements in Spanner, a lot of new innovations which we are bringing in. And I'm going to walk you through those. Second, Andre is going to introduce CERC to you, give you all the details about exchange receivables, and you'll come out as an expert in that. Because of Andre. And last but not the least, Pritam is going to talk about the technical details of the CERC Spanner use case and all the nuances which are associated with it. At the end of the session, we expect to have some time left for questions. Even after the session is over, all three presenters will be here in the room to answer any questions you may have about Spanner or anything related to CERC. So let's dive right into it. Before I talk about the Spanner innovations, for those of you who don't know about Cloud Spanner, let me introduce it for you. So Spanner is a no-compromise database. It brings best of both the worlds, which is near unlimited scale, with which is horizontal scalability, along with full relational semantics for you. And this is a highly available database with 5 nines of availability. There's no concept of any maintenance downtime or anything like that. I'm sure some of you know that in addition to external customers, Spanner is used internally within Google to power a number of our billion-plus user products and services. So in terms of scale, Spanner does more than 3 billion requests per second and has more than 12 exabytes of data under management, which is quite considerable considering it's an operational database. Now, oftentimes, when customers find out about Spanner, they come to us and ask us, where is Spanner the right fit? And based on the experience we have working with customers, we categorize Spanner workloads under these 4 categories. So first and foremost, it is for non-relational workloads which need some extra capabilities, whether it's secondary indexes, whether it's transactions, or in certain cases, they need SQL support. Second category is around scale. Means we just talked about the scale at which Spanner operates. Whether it's non-relational database or relational database, at extreme scale, Spanner is it for you. And it can be today, or you want to future-proof your application for the future, Spanner is the right database for that. And the third category is when you are running mission-critical workloads, whether you are in financial services or retail, and you want that 5 nines availability with that strong external consistency, Spanner is the right database for that. And last but not the least, a lot of customers have come to us and said, hey, I'm running thousands of MySQL instances or Postgres databases. And from an operational standpoint, it's taxing. So they want to consolidate in 1 or 2 Spanner instances and save on operational overhead as well as on cost. Now, going back on non-relational, we have customers like ShareChat who have migrated from DynamoDB onto Spanner and realized a lot of cost savings as well as the extreme scale at which Spanner can operate. Taking example from multi-regional, we have customers like Deutsche Bank who have built online banking solution on Spanner. In fact, Deutsche Bank is speaking along with my colleagues tomorrow and talking about their online banking use case on Spanner, so please feel free to attend this session as well. Let's talk about innovations. So we at Google, our goal is to provide best-in-class capabilities which help you build your applications by leveraging the operational data. That is our goal whenever we talk about development and things like that. We continue on focusing on enabling intelligence in Spanner by bringing in the power of AI ML for your businesses. And second, a lot of our customers come to us and say they want to drive insights from operational data. And for that, we make it seamless for our customers to leverage the operational data to do analytics and things like that. And third, our focus is always on developer productivity and how we can bring in capabilities which will make it much easier for developers to develop with Spanner. Now, coming back to intelligence, we recently GA'd the Vertex AI integration with Spanner. Now, you may ask, how does it matter to me? So imagine you are a retailer who is building a payments application on Spanner. And as part of that payments application, as you are doing the payments, you want to make sure that this is a safe transaction, and you want to enable all that via your development with Spanner. It's extremely easy with Vertex AI. What you have to do is just register your pre-trained machine learning model from Vertex AI into Spanner, and as part of your schema. And as you are doing that payment transaction, invoke that Vertex AI machine learning model with that transaction data, and based on response from Vertex AI, you can act accordingly within Spanner, if it's a safe transaction or not. Super easy to develop in one single application, and a lot of our customers are using it. I'll encourage you to give it a try as well. Continuing on the intelligence theme, sometimes it can be cumbersome to write SQL queries, remember all the SQL syntax which is there. So to help the developers, we are bringing in the power of Duet AI to Spanner. Now, I think if folks have attended the keynote today, there was a lot of discussion on Duet AI. Brad Calder talked about it as well. So Duet AI is an AI-powered assistant. It's available everywhere in GCP. And to help you be more efficient and effective at what you do. And with Duet AI-powered Spanner console experience, what you can expect is you can just give it a natural language prompt, a simple prompt where you want it to write a query or something. And as long as Duet AI is enabled, as soon as you click on it, it will generate a SQL query for you. So making it extremely seamless, extremely easy for you to develop with Spanner. This is all available in preview today. And as part of the Spanner Studio experience, we are bringing some additional capabilities to you. There's a dynamic object explorer, which is shown on the left of the screen over here, where as you register new objects, whether it's tables, views, they will be automatically populated, extremely efficient for you from navigation standpoint, as well as a new SQL editor where you can do all kinds of DDL, DQL, DML kind of queries. So extremely easy, making it easy for you to use. Now, in addition to thinking about intelligence in the databases as Google, we are focused on developing new technologies that enable user to make the most use of their operational data. Now, let's think about what kind of applications typically run on Spanner or any operational database for that matter. So if you drive your attention to this diagram, you definitely have your transactional application here. Then in addition to that, you might be doing some analytical queries on top of your operational data. You might be exporting your data from the operational database. Or you might be doing AI/ML batch queries for training purposes and things like that. Now, if you focus your attention on this gray block over here, which is a high-level representation of Spanner architecture, all those queries go through Spanner frontend and then leverage the Spanner backend, the provisioned CPU, which you have done and which you are managing. And we have full disaggregation of storage and compute with data being accessed from Colossus. So in effect, all your queries are actually competing for the same provisioned CPU. Now, how do we solve for that? How do we make it seamless for you so without any concern, you can do all kinds of workloads without having to impact your transactional application? And this is where I'm super excited to announce Cloud Spanner Data Boost. It's a breakthrough technology, game-changing in a lot of ways. And what we have done in Spanner over multiple years is we have developed a technology via which once you, as a developer, you enable Data Boost, and what we'll be doing is there's pre-provisioned compute managed by Spanner as a service, which is hot compute, so there's no startup time or anything like that. We will automatically use that compute to access data which is sitting in clauses. So it's the freshest data access just based on a single button click which you did, and we read the hottest data which is there without impacting your provisioned compute. Now, you might be thinking, why is it so game-changing and how does it help me? So there are multiple benefits for Data Boost. First and foremost is workload isolation. So now, without being concerned about impacting your transactional application, you can do analytical queries or data export and everything via this Data Boost technology, still have access to the most recent and up-to-date data, but your transactional application is not impacted. Second is about performance. Earlier, you were constrained by the amount of provision compute, or you were over-provisioning just to accommodate for some of these ad hoc kind of data egress requests which you were receiving. Now, because we take care of that provisioning and everything, because we do on-demand allocation of resources for Data Boost, you don't have to worry about that. So from an operational overhead perspective also, it's very beneficial. And all this at a very optimal cost, because it's pay for exactly what you use, Data Boost as a service. So we only bill you during the time when the query is executing for the resources which it consumes. And last but not the least, by this time you would have understood, since there's now a single copy of the data which you'll be using for all kinds of workloads, whether it's analytics, whether it's transactional. So you are having less of a challenge with data governance. You are not setting up expensive data pipelines or things like that to make a copy of the database. So from a data governance perspective, it's much easy and seamless for you to operate Spanner. Now, if you direct your attention to the slide on the top, the chart, so you can see once a query was executing using regular Spanner, it's consuming provision CPU, but as soon as it was done using Data Boost, there's no impact on provisioned CPU. Same thing on the performance side. In this particular case, it's saying 8x performance improvement, but internally depends on the query. We have seen much better performance and much higher performance gains with Data Boost. Finally, I'd like to drive your attention to a developer productivity capability, which we are announcing in GA today. This is auto-generated keys. So now, with auto-generated keys in GA, what you can do is you can just have the keys, primary keys, to be auto-generated inside your schema rather than in your application. And we have designed auto-generated keys in such a way that it does not impact Spanner's scalability, performance, and reliability. And the reason is Spanner is a distributed database, and as keys are auto-generated, these are not monotonically increasing primary keys. These are randomly generated unique keys, whether it's UID or integers, and this prevents hotspots. And in addition to auto-generated keys, we are announcing sequence integer support as well, which was a highly requested capability from a lot of our customers. So something where developers can use it and can quickly enable it even in their existing applications. And with this, I'd like to hand it over to Andre to introduce CERC to us.
Thank you, Vaibhav. So CERC is a Brazilian fintech, and we are innovating the use of the receivable in Brazil. Okay, to better understand what are receivables, so we have here ideas. So receivables represents amount that someone will receive in the future. That's the main idea. So we can create receivables by individuals. So I will give an example here. If you have a bill provided by your company that provide water to your house, you can pay later the bill, so you can create a receivable in this situation. But companies can create a receivable between each other. So if you provide something and issue an invoice, the invoice can be used as a receivable in that case. In Brazil, this market is huge because everything can be used as receivable there. And we started to study this market in 2015, and we applied for authorization to the central bank to try to organize this market. Central bank gave us authorization in 2017, and we started to work as a FMI. So FMI, you can make a comparison between here in US with New York Stock Exchange. They organize stocks. We are doing the same, but we are organizing exchanges with receivables. So here you have a small landscape that we are working. So we started to work with trade repository or trade receivables in 2017. After we start to work with time deposits, after loans, and here we have a specific situation with credit card receivables. So in Brazil, if you pay a dinner for your wife, for example, and the merchant just will receive the amount 30 days after the transaction. So we created a receivable in this situation. I will explore this use case later, but after this, we started to explore another business like insurance, agribusiness, real estate receivable, and now we are working with tokens, asset-backed security, legal claims, and a curious receivables here is related to wage. Everybody here is in this audience have a way to receive in the end of the week or the end of the month, so we are organizing how this wage can be used as a receivable in this situation. So, how the market was working before CERC. The first step, a receivable is created between companies. Someone provides service and create a receivable to be negotiated. So company presents the receivable to a bank to ask about credit, and now here we have problems because banks start to understand more data related to receivables, but they don't have data. So they didn't know information about if the receivable is available. They didn't know relate information about the behavior of the receivable, who is the real owner of the receivable, and we have a lot of information asymmetry here in that situation. What happens here? So first problem, frauds. Okay, we have a lot of frauds in this situation, but the most important problem is rates. So in Brazil, you have high credit rates. In credit card, for example, you have more than 100% of rates a year. So it's a good market to the banks, but for the companies, it's not so good here. But they need money, they make the transactions, and banks get the receivable to use as a collateral here. So companies expect to receive the amount in the future, and the end of the life cycle, banks expect to receive the money, but in some cases, companies don't receive the money to pay. So in this case, banks can charge companies to receive the money. How we are addressing this problem? So we are split in 3 pillars. The first one, we check if the receivable exists, okay? We have an engine, we call internally asset assessment, and we provide a lot of information related to receivables behavior, and we verify the existence of the receivable. The second pillar is related to if the receivable is available. We have an internal database that controls every situation about the receivables, and we provide this information to the banks. And the last part, we have an engine that controls the entire receivable life cycle, but the most important part is related with the money, if the money will back to the lender. This part is important because everybody that's lend money expect to receive the money back. So with this, we help them reduce the risk of the operation here. So how the market is working now? So the beginning is the same. A receivable is created, and now the second part is different because the receivable is registered at that CERC, and in this part, CERC works as a notary here. So imagine how many transactions we receive about every receivables. So everybody send the information to us, and after this, the flow is the same. companies presents the receivable to a bank to get credit, but now we have two use cases here. The step 4 is a little bit similar because banks start to understand more information about the receivables, but they ask to CERC about this information. We provide the information to the banks, and after this, they make the transactions. But the second part is most important here because we have every receivables here. So banks contact us directly, receive the information about which receivable is available, and banks start to interact directly with the companies here. And they make connections offering credits to them. So the logic here now is inverse because the companies can negotiate with the banks more because they have more banks offering credits to them. And here we expect to reduce the rates of the transactions here. So after this, the banks lends money, make the transactions with lower rates here, and they expect to receive in the correct date. In the end, happens the last magic here, because in the last day of the receivable life cycle, the money start to be tracked for us. So you check if the money will receive the money back. If they don't have money, you try to get more guarantees for the operation. So you try to collect more collateral to use in this contract. And of course, if we found collateral, we reduce the risk. If we don't found more collateral, we send information to bank, make the charging with more efficiency here. So to better understand more our numbers, if we sum up every receivable that we are working, you will have more than $5 trillion in receivable available to be negotiated. That's the Brazilian market that we are working. But now we are just working with $700 billion here. So it's a huge opportunity here. You can increase 7 times more just looking these receivables. But as I said before, everything can be used as a receivable. So you can explore more opportunities with other kinds of receivables. But for now, we are just working this situation here. So this slide explains why we are here. So in credit market, you have a specific situation in credit card. We have merchants. In Brazil, we have more than 4 million merchants. You have acquirers, 200 acquirers. Acquirers is the owner of the credit card machine. FMIs, competitors. So we exchange information between us and banks here, more than 500 banks. During the day, transactions happens between individuals and merchants. Every transaction that happens, acquirers receive this information during the day. And during the night, they send the information to us. So we receive the information, and we organize this information in our database. In the beginning of the day, like 6 a.m., we provide this information to the banks here, to the financial institutions. In the beginning of the window, 9 a.m., between 9 and 11 a.m., the banks and merchants start to negotiate credit here. So there is a lot of transactions to be negotiated. If we multiply merchants by acquirers, by credit brand, like Visa, Master, type, credit, debit, by day, and they here will have 2 situations. They can negotiate transactions that happened in the past, but they also can negotiate transactions that will happen in the future. So the banks buy the future of the companies, so specific situations, but there is a lot of transactions here. If we multiply every situation here, you will have more than 1.5 billion transactions to process in a couple of hours here. So when we start to study this, we start to study database, because we had, in the beginning of this workflow, a lot of uncertainties related to this flow, how the market will work, etc. And we chose the spanner as a main database. So now I will pass the floor to Pritam, and he will help us to understand better our use case with technical details. So.
Thank you, Vaibhav, for highlighting Spanner's innovations, and thank you, Andre, for educating us about Brazil's receivable market and the role CERC plays as one of the most significant FMIs. So the previous architecture that CERC had served its purpose, but as they got into the credit card receivable business, the volume of transactions increased. And around the same time, the regulations were changing. So there was a lot of ambiguity involved in it. So not only did they need an architecture that was designed for scale and performance, but also they had to future-proof their architecture. So what I would like to do is I would like to walk you through CERC's business requirements and then translate them into technical requirements for their architecture. So first, as Andre pointed out, that CERC processes about 80% of Brazil's credit card receivables, and a major player and they are a major player in the receivables market. So they needed a system that was highly available. So no downtime, no maintenance windows, and the SLA for availability had to comply with the SLA that was required by the regulators. Second was scale and performance. So we will see in the next slides that CERC's workload is highly cyclical. So the system and the architecture they adopt had to make sure that it works with cyclical workloads without compromising on performance. When it comes to performance, they had to make sure that the database and the architecture they choose would process up to 150K transactions per second in this complex architecture without compromising on performance. And again, they had to choose a database that would allow them to fire analytical queries against operational data without compromising on performance. We are talking about financial data. So security was top of mind. They needed customer-managed encryption keys. They needed RPO0, RTO0. They needed to take daily backups. Last but not the least, they needed an operational database which had very, very low overhead. So the price performance was very, very important. So let's take a look at their architecture and see what the transactional workflow, which is the write workflow, looks like, and what does the read workflow looks like. So what you will see here is transaction IO. That's like the gateway into CERC's system. And to the left of the gateway are all the CERC's customers. So these are credit takers, payment processors, lenders, other FMIs. All the interaction with the CERC's system is happening through transaction IO. The PubSub provides loose coupling between transaction IO and the rest of the system so that they can scale independently. The prioritizer works hand in hand with memory store to prioritize the incoming request according to business rules and also order them. And once that is done, the transactions are passed on to book data, which is one of the most critical modules in the CERC's architecture. The book data has the business logic to process these transactions. It runs on Kubernetes. It can scale depending on the workload, and it writes the data to Spanner. Again, here the Spanner serves as the source of truth, and it stores all of CERC's transactional registers. So Spanner is extremely critical to CERC's business. You will notice here the use of BigQuery twice. That's because they wanted to store operational logs. One of the requirements that they had was ability to recreate any transaction. Right? So for purpose of debuggability, for purpose of auditing, you want to be able to recreate a transaction. So what happens here is that before the transaction is processed, the raw transaction is written in BigQuery, and after the transaction is processed, it is written again in BigQuery. So that way, you can recreate, you can search, you can debug any transaction you want. But remember that Spanner in this particular architecture serves as a source of truth for all the registers, because we are going to carry that to the next slide. So now look at queries. The queries from the users can come via two sources. One, it could be a batch request. So you request queries in batch. The other one is ad hoc queries, complex queries via user portal. Both these types of queries are served up via BigQuery. So BigQuery can, it has a lot of data which is joined at BigQuery, and it serves up. In the previous slide, we saw that the source of truth for all the registers was Cloud Spanner. So the Cloud Composer here pulls the data from Spanner and puts it in BigQuery. Cloud Composer is managed Apache Airflow for distributed job management, and it uses Data Boost, which Vaibhav talked about, to get the data out of Spanner and put it in BigQuery. So at peak time, during peak times, this is done 5 to 10 minutes, every 5 to 10 minutes, and during off-peak times, they do it every hour. So this is the way the queries are served to the end customers. Now, CERC has a very cyclical workload. So 9 to 11 a.m. local time is when they see the heaviest traffic. And on Mondays at around 9 a.m., we see peaks. On weekends, there is very little traffic. And sometimes when you look at the graph, the variation, the daily variation in the traffic is 10x. So what it means is that you need elasticity from your database without compromising on performance. But this also means that you cannot just throw more resources and over-provision and throw money at it. So you really want a system which is elastic, but you should be able to scale and pay for your actual usage. So what I want to show you is what happens when you scale a system like Spanner up and down. What is the impact of that on performance? So if you see here, the x-axis is obviously the timeline. The y-axis on the left is QPS in thousands. The yellow line is the QPS. So this is the incoming throughput. And you can see the surge in the incoming transactional traffic. And the blue line is the number of nodes. So the y-axis on the right shows you the number of nodes. So this is a classic case of auto-scaling, right? The traffic increases, the number of nodes increases, the traffic decreases, the number of nodes decrease. So no magic here. But what I want to show is Spanner is able to scale up and down based on the demands of the system. So you're not over-provisioning, you're not overpaying. But what is phenomenal is the red line here. This is my proxy for performance. This is the latency line. So regardless of the incoming traffic surge, you can throw 100 times more traffic. The latency and the performance remains steady and flat. So that was the impressive thing we noticed. So in terms of volume, total 300 terabytes of data is stored in CERC's instances. The largest instance is 187 terabytes. The number of nodes vary from anywhere from 115 to 500 nodes. And at peak, it's roughly around 100K QPS or 100K transactions per second. And total in a day, like Andre mentioned, it's about 1.4 billion transactions a day. Vaibhav talked about Data Boost. I showed it to you in a couple of architectural diagrams. So just like the autoscaler, I wanted to show you the impact of running analytical queries on the system, on your OLTP system. So let me orient you a little bit. So the top graph is the throughput graph. So this is an analytical query that is run using Data Boost. The y-axis here is the amount of data that we are pulling out of Spanner. The bottom graph is the CPU. So what I wanted to show you is that at around 5:50 a.m., when an analytical query was issued using Data Boost against your operational traffic, what was the impact of running this analytical query on CPU? So the yellow and the blue line you see here is actually the CPU because of your OLTP and transactional traffic. The red line, which is pretty flat here, is the impact of running Data Boost. So the TLDR here is there was absolutely no impact of running an analytically heavy query on your operational traffic, right? So that was pretty amazing. So now let's take a look at what is the impact of running Data Boost on your latency. This was through CPU. So similarly, the top graph remains the same, but I replaced the bottom graph with latency. So y-axis is millisecond. At same time frame we are running the analytical query. We are pulling out gigs of data, but there is no impact to the transactional latency. So your business basically is unimpacted. You can run any amount of analytical query that you want. This is a pretty amazing quote from Andre. who is the principal engineer at CERC, he basically feels that Data Boost has been a game changer for CERC. It allows them to run analytical queries without compromising on cost or performance. So no more custom pipelines, no more duplication of data, and no more taking risks with your transactional business. So what CERC has been able to do is they have been able to future-proof their application and architecture by leveraging a transformational database like Spanner that treats CERC's requirements as table stakes. Spanner has been better tested at Google scale. It has a lot of very innovative and interesting features, including AI/ML features, one of which Vaibhav talked about. We have a very interesting roadmap of things that we are going to launch soon. And also, last but not the least, when I think of true cost of ownership, it includes operational cost, licensing cost, hardware cost, maintenance cost. If you have a maintenance window, then there is cost of lost opportunity. So in CERC's case, because they are using Spanner, their true cost of ownership is really awesome, and they're very happy about it. With that, I'm going to give it back to Andre to help us close.
Thank you, Pritam. The solution was a game changer for us because we increased in clients a lot more. Today we have more than 500 clients, active clients here. And how we said before, you are processing more than 8% of the credit card transactions in our system today. And we are excited to use other solutions in our platform. The first one is the integration with Vertex AI, because you can offer more analysis in real time for our customers there. And we are building the next generation of our receivable platform here. For next year, we expect increase 5 times more transactions because we are exploring more receivables, and we have a lot of work to do with Google to receive this information and, of course, to provide more service with our clients. So now this session is over here, and we have here another sessions related to Spanner and database for you explore during this journey. Okay, and it's important for us to receive the feedback of this session. So you can use the app and give us information about this presentation to improve for the next year.